Okay, good afternoon, everybody. I'm Mike Keating, and on behalf of the MGIA, I'd like to welcome you to our briefing this afternoon, which is being delivered by Broadstone. Before handing over to our presenters, I'd like to run through a few housekeeping points, if I may. So first and foremost, please ensure your microphone and camera are off. If you would like to ask a question, and we obviously encourage all questions, please use the chat button at the bottom of the screen. We will look to answer as many questions as we can during this afternoon's sort of webinar. Any of those which we can't get to, then we'll certainly answer in post the event. The MGA's Programme of Learning and Insights has been accredited by the Charter Insurance Institute for the quality of content and supporting materials, with CPD hours applicable if relevant to your ongoing development. And the recording of this briefing will be available on our website and the MGAA YouTube channel, with the PowerPoint presentation to follow post the event. Finally, and just as importantly, you'll be sent a feedback survey post-event. Please do take the time to complete this, which will take no more than 2 minutes, as clearly your feedback is very valuable to ourselves and our members in terms of ensuring the best quality of our events and briefings. So, without further ado, let's get to today's briefing, getting the most out of AI without breaking the bank. And this has been delivered by Bharat Raj, FIA Head of London Markets, and Greg Bingham, Head of Financial Modelling, both of Broadstone. So I'll leave these gentlemen to briefly introduce themselves, and I'll come back in at the end of the briefing for the Q&A. So over to you, Bharat.
Right, yeah, thank you, Michael. And thanks for that introduction. So we'll start briefly just to introduce ourselves. So Michael's already done a little bit. So I'm Bharat Raj. I'm a general insurance actuary. Got about 20 years experience. I've been at Broadstone for about 1 year now. I've spent 10 years in consulting prior to that, and lots of time in the London market and in-house company roles, as well as previously in consulting roles as well. I'm joined by Greg, who's going to be running through a lot of the AI materials today. So over to Greg.
Everyone, I've been with, actually joined a company called OAC back in 2011. They were bought by Broadstone about 18 to 20 months ago. So I've been with Broadstone for 13 years. Now lead the financial modelling team, so we develop models in Money, Python, Power Query, R. We manage a team of developers working with insurance clients, develop models for life and for GI. So if you get a quote from a major bank in the UK, it could come from one of our systems. And that's probably for me. Bharat, back to you.
Thank you. Should we move on to the next slide? So just to recap, and this was on the invitation as well to today's webinar, our learning objectives. So what do we really want to cover today? We hope by the end of this session, if you don't know already, you'd be able to list a few of the off-shelf AI tools, so stuff that you can just buy readily, openly available to everybody, and not for thousands and thousands of pounds. So relatively cheap AI tools, powerful but cheap. And then talk about what some of the strengths and weaknesses are of these tools, what their limitations are, and we'd run you through today a few use cases, so you have an idea of what kind of applications there are for these applications, and then really then think about how that applies to your own business. If you're working in the insurance industry, what are the sorts of processes and areas maybe that you can use to that you can enhance or look to modernize with some of these tools. And then talk about, how it increases your ability to tackle things like efficiency, automation, reduce your business operating costs, and so on. So those are, some lofty objectives, but that's what we plan to go through today. Before we dive into the actual presentation, we'll give you a really quick run through of what Broadstone is and what we do. So we're not a tiny firm, but we're not not the big four either, or anything quite that scale. So there are 650 of us. We cover a few different specialist areas, lots of actuaries in our business, and lots of technical modeling folks such as Greg. And broadly our divisions are, we've got insurance, regulatory and risk advisory, which is the division that Greg and I sit under. We also have a pensions consulting division, an employee benefits division, and investment advisory. And we do work together on various complex projects. There are opportunities for us to call our colleagues from other areas as well and collaborate. We've been members of the MGAA since 2023, and as part of that, we are providers of actuarial services to MGAs, insurance carriers, intermediaries, and other sorts of businesses related to insurance. So what we're going to talk about today, so we'll do a really quick introduction to motivate the presentation. Mainly, we're approaching AI in today's discussion from a programmer, a developer perspective, because that is actually one of the areas where it's really shined. And then we'll show you, rather than talk you through examples, we'll actually show you, demonstrate what it's like to use this in real time and how relatively quick you can get pretty complex problems solved. And then finally, we'll just leave you with a few thoughts. The two demos that we'll do, one is Greg will run through processing of a bordereau from scratch. So with absolutely nothing but some coding tools to a place where you've got a repeatable process. And then we'll go through something where we build a sort of geocoding and visualization dashboard as well. And just show you how quick and easy that is to do with some of these tools. Now, AI gets a lot of attention, a lot of hype, especially in the last couple of years. And there is lots of expectation that it can change our lives. And this is, it's a little bit of a gold rush, to be honest, and over-promising. There's no doubt that at some point we will get to a place where the AI is so clever it can solve really general problems, but that's not where we are at the moment, and there isn't any platform out there that is reaching that level of human intelligence. It's simply not there. When we'll get there, we don't know, but I guess for purpose of today, we're focusing on what's possible with the technology that's widely available right now. From what we've seen and the work we do, we have some general rules of thumb, really, on what are good uses of AI and where things don't go quite so well. So where you have a process where you are partnering a person with AI, so it's not AI doing things where you expect a human being to do, that would work. But if you went the other way and you think you can replace people purely with AI, that's certainly a mistake. And more likely than not, you're going to be disappointed, and the AI is not quite clever enough. It's not going to deliver, to be honest. It's also another good rule is to try and use this AI to augment existing tools, existing platforms, rather than rip it all up, start from scratch, and build AI at the center of it. Again, the real tools we have today, they're sort of language models. They're nice little add-ons that can make you more efficient, but it's not necessarily something that's a platform or solution in its own right, we don't think. And then the final thing here is you got to keep it really specific. So if you design a process and make it really clear what you're using the AI to do, quite narrow, that's probably going to work. and the AI is relatively predictable in that setting. But if the minute you start to generalize and you don't define those tasks so well, then that's where you've got lots of room for error, and you need to be managing that thing, on almost a minute-to-minute basis, and it removes the benefits that you are looking to gain in the first place. Now, this is the segue into what we're actually going to talk about in more detail, is how we use AI in an insurance setting, which is largely to do with supporting programming languages. I'm sure everyone's familiar with ChatGPT by now, and it's very, very good at writing poetry, telling stories, good at all sorts of language tasks. And actually, it's really, surprising thing is that it's actually good at programming languages. So things like Python, VBA, C++, there are a number of programming languages where it's really, really good. So that's where we found the best applications for this in our day-to-day. If you want to just click on, Greg. So here's a useful analogy. If you think that Greg, our programmer, he's like a calculator, when you partner him up with a little AI to help him with this, you've turned this little handheld calculator into basically a spreadsheet. So there's so much more that we can do on an Excel spreadsheet. Loads of calculations in parallel. So that's really what we plan to demonstrate today. I'll give you a flavor of. I think that's just repeating what I've said, really. So what are the basic necessities to get you started with this? The point of this slide here is to, first of all, show you some of the key tools that are being used by people very widely. But it's also to emphasize that they don't cost very much, or in fact, they hardly cost anything. The first four on this list here, from Visual Studio Code to GitHub, you can get these for free. These don't have AI built into them, but these are essentially the platform that AI is really good at supporting. So, for example, if you want to develop any specific code, you'd use a package called Python for this, which is second from the list. You'd be coding it in, your code editor is called Visual Studio Code, and you'd use GitHub to control your versioning. So you have a proper process of updating and upgrading and modifying your code over time, so you don't lose track of everything. All of these applications are free. The other two at the bottom, these are very commonly available AI add-ons, and what they do is they actually sit inside these other platforms, and you'll start interacting with them, and they can read your code, and they can recommend different code, they can recommend solutions, and they interact with you, basically using natural language. So you'd speak to it like you're speaking to a person, really. And you can see that the cost there per user, it's not high at all. And that's the point that we wanted to emphasize here. If we move to the next slide, please. So before we get into demonstrations and everything, I'm conscious, maybe there are a few of us who haven't seen a programming screen before. And don't worry, we're not going to terrify you with lots of code. What we want to do is just familiarize you with what the screen is and what you're looking at. So the you've got here a screen that Greg is going to be interacting with. You'll have a space there for you to put in your code, and then you hit the play button, and then it immediately on the line underneath that it shows you the result of running that code, what it does. So it's just a snapshot. So this is actually a way to build up a program piece by piece, if you like. And then over on the left, you've got a list of the different, what we call modules. So a module is a collection of, a series of lines of code together. So you can do something a bit more complicated, a bit more interesting. So that's hopefully a good introduction to what the screen is, and it's not going to scare anybody. And then finally, once you've built your code and you've organized it into modules, you might want to set these things running. So there's a little box at the bottom of the screen where you can just give it the final instruction to say, can you run this module or run that module, or set off a sequence of modules to run in parallel, or one after the other, or something like that. So that's what that final screen is for. And for most of this presentation, I think that we don't need to pay too much attention to that. Can we go to the next slide? Okay, over to the example. So in this first demo, we're going to start with a claims bordereau, really pretty standard one. It's not real data, so it's all made up, but the size and the shape of it, and the sorts of fields and columns, that's going to be familiar to most of us if we're working in insurance. And the business here is motor third-party liability, just to give a bit of context. And what we're going to do here is from just the raw bordereau, so essentially a spreadsheet, we're going to use this AI to develop a little module to, first of all, upload the data, analyze it, so turn it into graphs, statistics, and then once we get to a place where we can, almost get the key information that we want to get out of it and the process that we want to do with this bordereau, we will then generalize it so you can use it again and again, and in many times over many other files. So I think with that is over to you, Greg.
Okay, perfect. Thank you. Yeah, just a couple of, I guess, opening remarks from myself just before we dive into this. We've mentioned GitHub a couple of times. I think from my own perspective, that still seems to be not just GitHub, but source control generally in the insurance industry, out with the software platforms, is generally an underused tool for coding, and certainly from an actuarial perspective. It's something that we've used for 12 years. We used a different software before switching to GitHub a couple of years ago. So definitely, if you haven't looked into that, it's worth going on. And the second point I was going to make was that this is a live demonstration, and I'm very much hoping that AI will play ball here as I go through the demonstration. And if it doesn't, then on a few times that I've gone through trying to prepare for this, I've managed to work around it fairly quickly. So bear with me. I should bring up the screen. So I've given myself a little bit of a head start in terms of bringing in some of the Python modules that I might need to demonstrate this, and also bringing in the data initially as well. So I'm just going to run all of that just now and just open this data separately so we can have a little quick look at the data and people understand what we're looking at. So this is within VS Code. This is a little extension called Data Wrangler. So you can load up data really quickly and see things like age in a little chart that I'll go into in a little bit more detail further on. So this is just some fraud data. So we've got some how long they've been a customer, age, some standard kind of policyholder information. And then right over on the right hand side, we've got what kind of incident was going on for these vehicle accidents, authorities contacted, where it happened, location, number of vehicles involved, and then things finally you get to whether any fraud was reported in here. So you can probably use this data set if you've got a little bit more time and done some cleansing to get into possibly some machine learning a bit further down, and as part of that development. So just to give you a flavour of what that data looks like here before I try and perform any analysis on it. So the first thing I've done here is pull in the data and just display. So df.head is just to display those top top 5 rows, and I've opened it in a Jupyter notebook within VS Code. Might be quite a few of you familiar with Jupyter notebooks that typically live within a web environment. I think they're quite neat to work in with VS Code, and that works quite well. So I'm just going to give myself an extra code box. So as Bharat said earlier on, we've got GitHub, and we've also got GitHub Copilot. And GitHub, the best thing I can probably say about GitHub Copilot is that it lives within the coding environment in VS Code here. So I've worked on projects where we've worked with ChatGPT or Microsoft Copilot, and you're constantly copying and pasting back and forward code in order to get where you want. It can't see the rest of your code for any context, and it becomes a bit of a copy and paste exercise. And I'm not saying there's not a bit of that goes on, but there can be. But the most crucial bit about this is that I can actually put a little hash in here. And then I can start to type in what I want. So I'm going to ask it for some summary statistics, and then immediately it's going to give me the code for that. So if I can quickly tab, and then instead of reaching for some mouse, I'm going to do shift and return, and immediately it's going to give me some summary statistics on that data. So the one I want to focus on here in particular for the purposes of this quite quick demonstration is the age category. So if we look at the age category, I've got some minimums 19, max 64, and then we've got like a mean of around 40. But what does that really kind of look like? We already saw a little chart on the other page. So I'm going to try and dive into that a little bit. So I can ask AI again, can you give me summarize the count of ages there, and immediately I've got the count of the ages, and I can run that, and I can see that the most popular age in this data is age 43, and the most of the popular ones are hovering around that kind of 38 mark. But this is relatively clear here, but it'd be better if we tried to look at that in a chart. So I'm going to now ask it to draw a histogram of that. And that quickly, as you can see, gives me a histogram here, and then I'm going to run that, and it gives me a histogram of the ages. So I've got a histogram of the ages, and I can see what kind of distribution that looks like. But if I wanted to take this image and put it into a report, for example, I'm not really sure that this is the image I'd like to take to a report. So the beauty here is that I don't really need to know in detail what I'm trying to do with this code in order to try and it can be quite tricky to come up with all the exact syntax that you need to prettify this and make this suitable for reports. The first thing I'm going to try and do is group the data into 5-year increments, just to try and look at that histogram again, tidy that up a little bit, because having every single year is not overly useful. Let's see how we get on with that. So we're not going to... So as caveated early doors, we've got some age bands coming out with a 20-year age band. So let's try that one again. And then we'll try and draw the histogram again. There we go. So that's starting to look a little bit better. But unfortunately, we've got like a little bit of gaps either side, so we can try and eliminate those Again, yeah, it has hopefully worked out I want to do that. So perfect. We've now got something that's started to look a little bit better. Fortunately now we don't really seem to have any labels on this, so I'm going to try and put some nicer x-axes on here, and then also put some labels on the data as well. So, and I'm going to ask it to label the axes as well. There we go. Just going to bring this up a little bit. Got x-axis and a y-axis. So and it's going to put a title as well without me even asking it. Perfect. So we've now got a label on the x-axis. We've got a fairly pretty x-axis, which has gone a little bit further than I intended. So we could just fix that very quickly if we take it to age 66. So we've got that. So we've taken away the white space at either side here. We've managed to add x-axis, y-axis, and a header. And as you can see from that, I've touched very little in the way of code here, and the AI has been writing all that code. So I've got last little step here that I want to do with this particular data. I still probably wouldn't be happy to put that into a presentation. I'd probably want to put it in some sort of branding or color as well. So I'm going to just ask it to do that. So Broadstone, we love this beautiful teal color. And yeah, so I'm going to border the black, and it's suggesting to make them a bit wider as well. So I'm going to just do that. I'm just going to ask it to make it funky. I'm not quite sure what that's going to make it do, but let's have a little look. Just going to put those labels in again. Okay, here we go. Okay, so it's not particularly funky, but we now have something which is in on-brand color, nice headers, x-axis, y-axis, and as you can see, if we go through the history of this, we've got to from something originally which is quite messy, really horrible to work with, and now we've managed to summarize that data nice and neatly. If we have that data, then we know that this is a repeatable process, and what that means is that we can take that away and allow us to basically replace the name of the data, the location of that data. And because I've taken it through within a Jupyter notebook, what I want to do now is just cover that such that I've got the code and I'm able to repeat that code. So I'm just going to give it some prompts here for it to think about rather than me type all that out. I've asked it to give me everything that I need in order to create that again. So let me scroll this up a little bit. So it's going to just spin through all that. It's going to give me everything that I need now in order to create that chart again. So create that chart again, except this time I can take all this information, including reading the data in, and I can copy and paste that into a separate Python script. And so that is the first part in terms of the claims bordereau presentation. But
Sorry, I was on mute there. Thank you. Thanks, Greg. That was really interesting. I think the thing that's stuck out to me, and maybe you can talk about this in your next demo, as you are typing prompts, the AI is already predicting what your prompt wants, rather than just predicting the code that you want. It's also predicting what you're asking to prompt it. So it's going that step further, which was just remarkable. So next we want to show you an example where it's a different data set now. We're moving on to something different and really pushing the boundaries a little bit more. And the point we're trying to make here is we can use it to solve quite complex problems and maybe starting to stray into territory where you might want to buy an off-the-shelf solution really for something like this. But actually now you can spin it up on your own just using Python and using a good developer in say the space of an afternoon or even less. So what we've got, again, we've got a data set. It is effectively is the list of all the pubs in the UK. Nothing controversial, but it's just their postcode. What we're going to do with that information is we're going to geocode the data, so get the longs and lats. Or maybe maybe we're not going to do that. I'm not sure. Like Greg clarify that. We might have dropped that due to time. And then we'll plot all of these pubs on a map of the UK, do some clustering analysis or density analysis, types of things that you want to do when you're looking at a portfolio of commercial property, for example. If you want to know where your exposures are geographically, so just to demonstrate that capability. And then finally, we will put it onto a dashboard which you can access over the internet. And other people who have no programming language experience or no coding experience can just go there and start interacting with the results of what you've done. There's also a link to this, which we've already got this up and running on the internet on our web page or on our Broadstone page here. There's a link to that there, so you can, and we'll keep that running for a while. So after the presentation, you can go back and just have a play with it. So yeah, back to you, Greg, to run through the demo.
Okay, perfect. Yeah, we've got just to clarify the point you were making, we've got the longitudes and latitudes on the data set here. So just going to open this data set quickly in Data Wrangler. Another beauty, I guess, of VS Code, and it tends to be a bit quicker at loading data than and manipulating data in this way tends to be a little bit quicker than Excel, for example. So we've got the names of the pubs, addresses of the pubs, postcodes, and the latitude and longitude there, and what local authority they're in. So that's the kind of information that we're working with now. And we're just going to do some, along a similar theme, just going to do some summary statistics here, and then go into the geocoding element of that. So in terms of pubs, what would be if you're trying to summarize a data set, what would be something you might want to look at? In this case, I've decided that we might want to group by name and show me the counts each. So we might want to see what the most popular pub name is, for example. So I'm just going to play that, and immediately I'm getting an error. So I'm just going to let it think. I can spot it because it's taking the capital letter there. So I'm just going to quickly change that. So we've got the most popular pub name in the UK of the 50,000 pubs out there is the Red Lion. But I also spotted in here that the third most popular pub name is actually Red Lion. Sort of as part of our analysis, it might not be perfect, but I might want to, for example, exclude the this from the start of that and see if that makes any difference to the analysis I want to do. And I'm not spelling live. Let's just see. So let's remove that and then look at the value counts again. And as you can see, Red Lion is still the most It's now Redline, which is the most popular because we've excluded the, but we've got 331 of them, and Royal Oak is still quite high up there with new in as well. So we can quickly, using AI and allowing it to write the code, we can quickly manipulate some of this data. And then the last thing I wanted or a couple more things I wanted to do with the names is actually, can you give me, sorry. So I keep the last word in the name. In other words, lion or in, for example. Show me the count of the names. So in this case, I'm going to look at the names, and actually, despite the fact that it wasn't appearing high in this list, the most popular pub name in the UK is Club, and that has over 8,000. So there are over 8,000 clubs in the UK as part of pubs anyway. And then finally, if I want to do some manipulation with that, I might want to see what percentage of pubs that represents in the UK. So, let's just see if that works. Yeah, so there's over 16% of pubs in the UK have club at the end of the name, and in is 13%. So we're about quite close to a third are clubs or in of the 50,000 pubs in the UK. And again, this is just a demonstration that we can quickly manipulate data without doing a lot of code at all. But what we really wanted to see here is how can we take that analysis a little bit further. So we're going to use a package here called Folium. And Folium is a package that we researched and found and is able to show locations of longitude and latitude as part of a map. So one of my colleagues, Richard Steele, he wrote an article for the Actuary magazine last year, and that contained road traffic accidents as part of that. And so we've created a similar app here we're showing off pubs, and it's not necessarily relevant for insurance, so it might be, it's just an example of how we can manipulate data in this way and show off the capabilities of both developing some of that code with AI, and then also the capabilities that we have of creating these sorts of apps or this type of analysis, potentially for your business. So I'm going to just give it, conscious of time here, so I'm just going to give it this prompt, which I've created earlier. So it's going to get rid of some of these errors that I'm sort of expecting. I'm going to create a map. Add a heat map to that map. Display the map. Perfect. Yeah. What was it? Just see if it displays it here. There we go. So it has created an HTML of that map, which we could open, probably not in VS Code, but in here, and then but elsewhere in a web interface probably, and then I've managed to demonstrate the heat map here. So we can look at the heat map of the UK, find out where the hotspots are of pubs in the UK. Probably no great surprise that there are not whole loads of pubs right in the north of the UK, and actually there's a big red blob in London here, but you can see that as you zoom in, you can see the particularly high density areas of London that have those maps in them. So as part of this, we can then take this information and take this map and then drop it into what we've developed, which is in a Python package called Streamlit. And as part of that, we've lifted this code along with about 100 lines of code in total, and we've put that into an app, which I'm going to just demonstrate to you just now. So as Bharat mentioned, this app is available for you to go and have a look at. So it's at pubapp.broadstone.uk.co.uk. There are a couple of things that are demonstrated in this app. There are 50,000 pubs in the UK, and so we don't really want to, if you load all the data, it will work, but it'll take a long time. So what I've done is actually allow you to focus on the areas that you would like to look at. So if I pick out Edinburgh, for example, because I know that really well, you can pick out multiple local authorities, for example, and when you choose that, you'll then get a little, instead of a heat map, you get like a little cluster map as you're shown here. So I can zoom in here, and it's already sort of clustering some of the pubs, but I can come right in here and choose one of the pubs. It's on the map, and then we can see the name of that pub. But part of the real value in this analysis is that, as well as just being able to demonstrate where pubs are on a map, which of course you can do with Google Maps, so there's nothing particularly fancy about that. What my colleagues done is develop some DB scan clustering, which I'm not going to go into too much detail in terms of how that algorithm works. But essentially it allows you to show, say, accidents or areas of pubs and look at how that might work in order to analyze some data. So I'm going to come up with a specific example here. So within 250 meters, show me areas that have 17 pubs or more. And when I look at Edinburgh, for example, then I get two clear, distinct areas of Edinburgh that have 17 pubs or more in it. And I can look at that clustering analysis of that area, as well as all the pubs around about it. And I can find out which pubs form part of those clusters. So you can see that for like insurance, for example, where we look at road traffic accidents and the clusters of those, we can quickly see those hotspots across the UK. People can maybe look at contacting or being in contact with local authorities, and in terms of town planning and those sorts of things as well. So yeah, feel free to jump on here and have a play around and find out more about where the density of pubs are in your area. And I shall bring the slides back up. Perfect. Back to you, Bharat.
Thank you. Thanks, Greg. And we're going to try, so we're going to maybe rush through the last couple of slides because we want to leave some time for questions. But hopefully that then gives you an idea of some of the problems that you can start to tackle, and you can start to do this relatively quickly. That's the point. The pub app that Greg went through, I mean, it took no more than a couple of hours really in the hands of an experienced programmer with the help of AI. You can start to do these things really quickly. So, I don't want to put a number on it, but it's multiple times faster than it was. There is an argument here that, you don't need a programmer anymore, that AI is really that good. And you can just start to then communicate with it in English and ask it to do certain things. But that's not quite our experience. It kind of gets you a lot of the way there. It takes the tedium of coding out of the equation, but then it still gets things just wrong enough that you do need someone quite experienced to manage it. So it almost elevates your most junior programmer up to, what a manager would be in a big programming team, if that makes sense. And that person's then just monitoring and managing and making sure that the code is actually doing what you want it to do. And the other point to make here is you don't necessarily need to set aside your own head count to have people in there just to work on nothing but coding. I mean, that's where hopefully people like us can come in. You can get us in there for a day or a week or however long you need to build whatever process you need built, and then we're off again. And call us back when you need any update or when you need anything new built. So that again helps to really manage costs over the longer term. The range of so I was going to run through a couple of things back there. The range of areas that you can start to solve, or problems that you can start to solve. I mean, there's a long list here, and we've laid them out. Some of the more interesting ones are to do with modeling and analytics, Python and other programming packages like R and so on. All of these are free, by the way. There is lots of existing pre-built libraries, solutions, very advanced tools that now you can start to access really easily. There are also things where, historically, you might have gone out to vendors to buy an off-the-shelf solution that does maybe 50% or 80% of what you need. And then you've had to build stuff around it, and then you're not using most of the functionality. Actually now it's coming to a point where you might have just build a solution yourself, or in some cases anyway, you could just build a solution yourself in Python. Once you've done that, you own the code, you own the IP, and you're not paying any licenses for the long term. And as long as you've got somebody in there who can come in and maintain it, as in if you've got other things upgrading or other systems moving around, just making tweaks to it to make sure it's still compatible with everything, then you've really cut a lot of cost out there. I'm not going to run through each one of these in detail, but hopefully you've managed to read that as I was presenting. Or if not, the slides will be there, so you can have a quick look at the sorts of suggested areas that you can tackle with this type of solution. And this is just to sum up, really. So what do we think are the benefits of doing this? So you can really reduce your development time. You can start to solve problems that you wouldn't have maybe thought were within your grasp previously. You're not paying lots of license fees. You're not paying a big part of your turnover to maintain things that are reasonably cutting edge. You can get solutions that are really tailor-made for what you need and what your business needs. The AI is very good at reading code and translating from one language to another language. So actually you do take key person risk out of this as well. So developers who are maybe not so familiar with one package can use one of these co-pilots to help them. And there's enough transferable skill there that you can pick up a new language relatively quickly if you're an experienced coder. And then finally, just to repeat the point that, you don't need to lay out loads and loads of cache or hardware even. Just a good developer, or even a developer on a part-time basis, would do it for you. So I think with that, hopefully there's a few minutes left for questions.
Yeah, okay, so thanks very much, sort of Greg and Barrett. So it's definitely time for a couple, maybe three questions. So first of all, a very interesting insight in terms of not breaking the bank with AI. I suppose one of the key ones would be, what steps can be taken to future-proof your work so that you don't have to circle back in 2 years' time and then develop solutions again. What's your advice on that?
Greg, do you want to take this one, or should I?
Yeah, go for it.
I think the main thing is to not over-engineer things, we think. So the future-proofing bit, I mean, if you've outlaid a lot of time, cost, and expense, you almost get stuck with that solution. And I think that would be the maybe the first recommendation there. Other things you could do, use packages that are very widely used. So rather than going into something that's really specific, really bespoke, Python is great because it's got such a wide take up internationally, and it's really reached the stage where it's very flexible. That's a whole pre-coded library, and millions of different solutions out there that you can just do a quick search on. And there are new ones being added every day, and all of it's, it's open source. And all of it's free. So again, that kind of gives you something that's long lasting. And we don't think anyway it's going to go out of fashion anytime soon. So those, hopefully that gives you a general idea of the sorts of techniques and strategies really to avoid becoming obsolete in some time.
Just briefly add this, you sort of touched on it there, but there's a lot to be said for good structure and code. So you can have massive libraries and massive code set up, but if you structure it correctly and it's separated, then it means that if parts of your code become a little bit dated or you want to replace parts of your functionality, then you needn't rip it up and start again. I think that's the beauty of Python and some other kind of packages there.
Okay, and if I could just add one more, actually, time for one more, and actually it's more focusing around GitHub. So, what is the benefit of using GitHub Copilot in comparison to more general AI tools, the ones we hear about, such as OpenAI, Google, Gemini, Microsoft Copilot? So I suppose the question is, why GitHub Copilot? How does that compare?
Yeah, I think there are GitHub Copilot, to be fair, is not the only one that does this. There are other kind of integrated AI tools, but I think that the key difference here that I've sort of tried to demonstrate is that GitHub Copilot is integrated with VS Code. It can see your code base, yet still maintains a certain level of privacy over that code base. And it means that as you question that code, you're not leaving copying and pasting bits of code from that screen, opening up OpenAI or ChatGPT or Copilot, Microsoft Copilot, and pasting that code in. That then Microsoft Copilot doesn't have any context around your code and what the errors mean or where it can look in your code to find those solutions. So I think it's that integration point that's the key. And like I said, there are other packages out there that do similar things, but I think that for me has made a huge difference in terms of the speed that we can code, because as you've seen there with some of the even it's guessing, or guessing's probably not the word, but it's suggesting some of the prompts, never mind suggesting some of the code. So I found quite often as I'm coding myself and not just purely using AI, then it will suggest the rest of the code lines that are in there, and it just speeds up the whole process. And it could be much slicker.
Okay, thank you very much. So it just leaves me, okay, we've just had another question just in, which I'm pretty certain we have time to do. So a question from one of our delegates. So what skills do you believe are most critical for insurance companies to develop internally when starting to use Python for analytics? Are you stunned?
Yeah. Yeah, I was just trying to work out.
Great question, clearly.
Yeah, I was just trying to work. I guess there's two angles of it. Is you obviously kind of need some of the Python skills. There are plenty of fairly cheap, like Udemy courses, for example, available out there, so you can get into Python. They will teach you both, because I think you probably need two sides to this. You probably need coding experience and coding knowledge, and then on the other side you probably need to understand how, I guess, the machine learning works and how those engines work. There are some courses that will do both, and it's worth getting into those kind of mathematical and statistical kind of base skills in terms of analytics, and even pushing forward into potentially machine learning and so on. So yes, there are Udemy courses and other courses out there that kind of cover both.
Yeah, I suppose the question is very apt insofar that there's always the danger that companies could start off on the wrong direction of travel in terms of internal training, which take a while to reverse round, as opposed to having the right professional advice and support of what is the right structured way in terms of training to develop those analytical skills. So I think it's a very important question, to be fair.
I think the one thing I'd maybe add to that is, you can't do away with having experienced developers. So you know that having that real years of experience in the team is kind of quite important. So yeah, I think just training people on this, if they haven't used it in real life, that they'll be missing that guidance, that wider understanding, and maybe to just start things going, you know, start with an experienced developer and then build a team around that.
Yeah, that's probably fair. I've probably undersold myself a little bit there.
Okay. Okay, well, I need to bring it to a close. So first and foremost, again, many thanks to Broadstone and Barrack and Greg for taking time to talk to our MGAA members today. Just before we finish, please complete the feedback survey, which I mentioned at the start. And if you've not already registered, please join us at the MGAA Claims Conference scheduled for the 7th of November at the Queen Elizabeth II Centre in London. And there's more details on that on our MGA website. But again, thank you all for joining us and have a fantastic afternoon. All the best.